What is up, guys? This is Merciless bringing you my first video for my physics thing I was talking about on my intro. If you haven't seen that video, go ahead and check it out. It's just go to the least recent videos on my channel and you should find it. But if you didn't, that's alright, because I got my first video here and I am on Minecraft. Let me set the time. Where's the time? I think it's time set. Yeah. Okay. So as you can see, you can't see very far because I just turned it down a little bit so it wouldn't lag, because I noticed my first video lagged a little bit. And so I am 48 blocks above the surface, because on my first video, for my first video I am testing gravity of Minecraft. I'm going to calculate the gravitational acceleration of this world, and so I'll explain all the mathematics later, but to conduct this experiment I'm going to be at a constant height of 48 blocks above the surface. As you can see, I'll fall to this grass block right here, and the constant, gravitational constant, will be calculated knowing that and knowing the time. Now I'm going to use my stopwatch, which is a very inaccurate way of doing calculating, but I'm going to go ahead and do that. And then I'm going to also use some software to get the real time by using that. I'll get a more accurate time, and with that time I can get the gravitational acceleration, as I'll explain later on in my video. So in order to conduct this experiment, I must not have you can't jump because that changes the height, and you must just completely fall. So you have zero vertical velocity, and your vertical acceleration is constant due to gravity, because I'm not being pushed by anything besides gravity. Except air, but air is negligible, I assume, in this situation. And so I am going to start my experiment. So I'm going to do 10 trials and calculate the time. And then I'll get back to you guys after I do 10 trials. Okay, I'm back now, and I am on PowerPoint explaining everything that I found in my research. And so here we go. So I'm going to start off with Isaac Newton's principles of forces and accelerations, which will bring us to little g, which is our gravitational acceleration that we are going to find. So let's talk about Isaac Newton's principles. Two equations are the first one is the second law of motion, F equals ma, and second one is F equals g times big M times little m over r squared. This is his law of gravitation. Force of attraction over two masses, one being the big M, which is our mass of Earth or mass of Minecraft, times little m, which is us, and the force required to keep us in the loop in gravitational field. So if you put them equal to each other and we divide by m, we're going to get acceleration, which is the equation we're looking for. But since we don't have mass or radius in terms of Minecraft, because it's not well defined, we're going to need another way. We're going to use one-dimensional motion, which is the motion in one dimension, such as the y-axis in our terms. And with this equation, yt equals 1/2 gt squared plus v sub o t plus y sub o, we can find g, because we know that v sub o equals 0, so that term cancels. And then we also know that yt equals 0 at t that we measured in the lab, so we can make that 0. And since g is negative because it's pulling downward, we can put a negative sign there, and then we could add it over to the other side, and then of that equation, we can solve for g, and we get this equation that we'll use for the lab. G equals 2 y sub o over t squared. And since we have y sub o, which is 48 meters in Minecraft, over t squared, which is the time we measured, we can find g. And with the data, so the data shows y sub o is constant at 48 meters, and the t is more accurate on our software, so we're going to use that one. And using that t and using that y sub o, we can find g, which is 26.59 in our case. We average just about at the bottom, but since it's consistent because it's software, it'll be the same for the average as it is for the data. 26.59 meters per second squared. Comparing this to Earth, it is about 3 times because Earth's gravitational pull is 9.8 meters per second squared. And so it's about 3 times close. And that means you would weigh more on Minecraft than you would weigh on Earth. Like a lot more. And I use these equations, weight equals mg, and then m equals weight in pounds times 4.449 divided by 9.8. And if you substitute that in, you get that equation at the bottom. And if I put my weight in on Earth, I'll get about 2,500 pounds.